Amazon. Thursday. I have a thought question for you. Since you happen to be on, all of you. Thought question is, as you were calculating a lot of parallel resistance in the past bunch of hours since we met on Tuesday, have any of you thought about this concept? Why, when we keep on adding resistors, in parallel, how come the total ohms goes down? Has anybody thought about that? It stands to reason when we've been building and playing with series circuits for a few weeks now, it stands to reason that when you have more resistors in series, you just adding the ohms together. 100 ohms plus 100 ohms plus 100 ohms in series, yeah, it makes sense. Okay, I've got 100 plus 100, that's 300 ohms. That's an easy concept. But you take the same 300 ohms in parallel, 300 ohms in parallel with 300 ohms in parallel with 300 ohms, you put them in parallel, how do we get 33.33 ohms? Where does that come from? Anybody think about that? You've done the calculations and successful at that. I've seen your work. So you know how to use your calculator and calculating.
It work.
But really, hopefully. But have you thought about why is it less? How can we end up with less ohms? Anybody think about that? Just thought I'd throw that out there. Because Co says so. No, not because Co says so. Not because of Ohm's law. Well, kind of indirectly because of Ohm's law. Okay, this will be coming along shortly. Good. All right. Anybody have any thoughts about that? What do you think? Ryan, any thoughts on that? I'm not just picking on just you know, any Luis, any thoughts on that? It's like, yeah, Co says it'll calculate less, and the formula says it'll calculate less, and I can do it on the calculator, and I get a number that is less. Anybody think about why? Greg, have you thought about the why?
Honestly, no.
No, yeah, I know. We're just chugging along. Co says do this, and you do this. Kirsten, have you thought
because we need more current?
What's that?
Because we need more current?
Because we need more current? Current has a lot to do with it, Tony. You're kind of on the right track with this thing about current. This is a little something else. What else do you think? Kirsten, do you have a thought on that? Why do we end up with less ohms when we add more resistors? What's that about?
Less ohms with more resistors?
Yeah, when we add more ohms in parallel, when we add more resistors in parallel, we get less ohms. What is that about?
So, okay, based on the formula with the reciprocals, as you increase the R, the value decreases because the reciprocal is in the denominator. Someone that's bigger. Yes.
Yes.
Something
Yes.
like that.
That is exactly it.
Okay. Sorry, I just got here.
And I'll help you wrap that up so everybody else can wrap their heads around it too. But let's do this first, all right? It was an interesting question that I just thought I'd throw out there. Anybody think about that?
Can I ask a question?
What's that?
Can I ask a question?
Oh, yes, Dana, please.
Is it like, so like the resistors are like thin pipes that kind of restrict the flow, but then if you have two thin pipes, more flow can happen than if there's only one? Like if
That's a really, did everybody hear what Dana said? Dana, could you repeat that a little louder, put your mouth a little closer to the microphone and a little more slowly, but you're on the right track.
So each resistor is like a thin pipe that restricts the flow of electrons. And when you have two in parallel, it's like you have two thin pipes that are flowing with electricity rather than just one. So there's more like pipe. So like they're right next to each other.
That's exactly it. We've added another thin pipe. So I'm going to demonstrate that for you. Let me get the right probes. I'll be right back. I was repairing a table lamp earlier, so I had my tools and measuring devices in another room. So let's go ahead and show you something. This will be circuit EFG, I think it's circuit I, something like that. Anyway, let me go and yank this guy out, yank this guy out, and let me use this pin here. Let me use this pin here. I'll get my camera on for you in just one sec. Okay, move the mouse, get the camera. All right. Now let's see if we can do this and share. Let's go to here and focus on this little guy. All right, and let's go to speaker view. Okay, if everybody can mute your microphones for a moment, that way the camera can stay, our field of vision will stay focused on the camera. If your microphones are not muted, then all of a sudden any background noise will cause your name to pop up on the screen and you rob the view. That's the way Zoom works. In any case, now we happen to have a single resistor, and the single resistor we will go ahead and measure for ohms. So go ahead and turn the dial, and it's not many ohms, but I'll put it on maximum of 2K, and I'll go ahead and hook this guy up here, and I'll go ahead and hook this guy up here, and try not to obstruct our field of vision. Okay, so it looks like we have something about 218 ohms thereabouts. So this is supposed to be a 220 ohm resistor. And if you trace the path for the meter to read, I happen to have a yellow wire on the red rail, and then it comes down here, makes contact with the 220 ohm resistor, jumps over the dip support groove, comes down here to this yellow wire to the blue rail. And normally I could have this hooked up to my power supply, which is presently not on the board. And as you remember, you cannot measure resistance while electricity is flowing through the circuit. So the power supply not only has to be turned off, but the power supply has to be physically removed. Otherwise, the power supply is still part of the circuit and can alter the measurements. So right now I have a single resistor, and it's 218 ohms. If I were to add another resistor, and this particular guy versus this particular guy, it looks like, okay, so this should be a 100 ohm resistor. So I'm going to add a 100 ohm resistor to the circuit. And when I add a 100 ohm resistor to the circuit, I'm going to add it in parallel. And so as your classmate Dan and Kirsten pointed out, both correct, we have another current path. We have another path for electricity to flow, which makes less resistance. Because how does an ohm meter work? In your reading, the ohm meter works this way. It's the battery, the digital multimeter is battery powered. And what it does is when you have it on a specific setting and the banana connectors are hooked up properly, it sends out a current. And as it sends out a reference current to a very specific amount of internal ohms. And depending upon the current that comes back based on the resistance here, it will show a certain amount of resistance. It's calibrated with the necessary code in the microchip to be able to decipher the amount of ohms that is being contributed by this particular resistor. How does this do this again? It sends out electricity. It sends out an electrical current. And how much current comes back to this machine based on a reference, it will say, oh, based on the amount of current coming back, I've got 220 ohms, almost 220 ohms in this circuit. I'm going to add another resistor. By adding more ohms, but I'm adding more ohms in parallel, as your classmates have stated, I have another current path. I have another pipe, if you will, for electricity to flow. So when I go to do this, I'm going to pop this guy in here. That's a 100 ohm resistor. Now I'm not going to show you the display. Why? Because I want you to calculate what the ohms will be. So whip out your calculators right now. Pull out your calculators and calculate 220 in parallel with 100 ohms. Write that down on a piece of paper. Don't sit there and wait for somebody else to call out the number and you copy it down. You want to calculate this. This is a participatory exercise. And it should only take you but a few moments to do this. If you don't recall how to do this, if you didn't get a chance to practice on the parallel circuit homework exercises that I gave you, let me repeat for you, the keystroke sequence is nothing more than, and I have lots and lots of wonderful paper here for you.
You said it's a 200 and 100?
220.
Oh, 220.
So I have a 220 ohm, and the double lines, let me do it this way. The double lines that I've written means this is in parallel with this resistance. So I now have 220 double lines means in parallel with 100 ohms. And the way you calculate the RT for these guys, if you recall, was 220, and you have to hit your reciprocal key, your X -1, and then you add. Then you enter your 100. Sorry. Then you enter your 100 and you hit your reciprocal key. And then you hit equals. Then followed by, let me raise the camera, you can see better. Thank you very much. Then lastly, followed by one more reciprocal and one more equals. So that is the keystroke sequence that you would use to calculate these two resistances in parallel. 220 parallel to 100 is 220 reciprocal, add 100 reciprocal, equals, then reciprocal, then equals. And so that being said, the calculation, I'm going to ask randomly, let's take a look. Francisco, you have a number for me.
I got 68.75.
Ah, 68.75. How many people would agree with 68.75?
Yes.
Yes, we got one agreement. Anybody else agree?
Yeah.
Thank you.
Agree too.
2, 3. It's nice to hear that confirmation. So I called out a number as hopefully somebody agrees. Yes, yes. Okay, so you were able to affirm something less than the lowest ohmic branch, right? Wasn't the total for parallel always going to calculate to be less than the lowest ohmic branch? And between these two, the lowest fellow is 100. So we said earlier, our total must calculate to be less than the total. And certainly, in fact, it has. So your 220, 100, and 68.75 ohms. Okay. And now let's go ahead and check by flipping this over and see if it does measure something close to the 68.75. And lo and behold, woohoo, 68 ohms. Wow, that's pretty good. Now, since this is on a scale of maximum of 2,000 ohms, right here, it's a maximum of 2 kilo. Do I have a scale smaller than this, but higher than the 68 that I could set my meter to? Yes. So you always want to start with a scale higher and work your way down for maximum resolution. So I started at 2 kilo. I can go down to 200 ohm scale. And at the 200 ohm scale, did I get one more digit of resolution in here? So I measured 68 point, and it's fluctuating between 6 and 7. So let's call it 6.5 ohms. Is that pretty darn close to our calculated 68.75? Yeah, pretty darn good. And so if we think back for a moment of the analogies that were given to us by your classmates, one more path for current to flow, another conductive pipe, another thin pipe added next to the other one allows more current to flow. So there's less resistance. And you can see that we have less resistance. Now I'm going to add one more resistor in here. I'm going to add a big guy. I'm going to add a 330 ohm resistor in parallel with the first two. So now this exercise is going to be 220 ohms in parallel with 100 ohms in parallel with 330 ohms. I'm asking for the R total. So why don't you all work on calculating that guy? Let me flip the multimeter over. I'm going to insert the resistor into its position right there. And what was our keystroke sequence? Let's take a look here. Harpreet, would you like to call out the keystroke sequence for your classmates? I'm going to write down what you call out. What should our keystroke sequence be?
The 220.
220 followed by?
The X to the power 1.
Okay, and we call that what key? It's called reciprocal key, yes?
Okay, reciprocal.
Reciprocal. Okay, then followed by?
100 plus 100.
No, okay, so we have a plus, and then we have a 100.
Yeah. Receptacle.
Reciprocal. And then followed by?
Plus.
Plus, and then followed by?
330.
330, followed by?
Receptacle.
Reciprocal, followed by?
Equal.
Equals, very good. Followed
And
by?
another receptacle.
Another reciprocal, followed by?
Engineering. Equal.
Equals one more time. Cool. And this should be small enough that we shouldn't have to hit the engineering key for these calculations.
Okay.
And thank you very much for calling that out. And for the value, let's go to, hey, Luis, do you happen to have the value for us?
Yes, I got 56.9 ohms.
56.9 ohms. 56.9 ohms. Many people agree with 56.9 ohms?
I agree.
Yes.
Okay.
Good.
Yay, it's good to hear that confirmation. So 56.9 ohms, correct. All right, and let's go ahead and flip this meter over, and guess what? We have 56.8.9. It's hovering in there, yes? Very good. So we are able to confirm our concept of R total always being less than the lowest ohmic branch, first confirmation. Second confirmation, we're able to confirm that the reciprocal formula works as you've practiced it, and we all consistently get the same R total, whether we have a 2 resistor bank or a 3 resistor bank. And we also have confirmed the concept that by adding one more resistor, it's still another current path. Adding a current path allows more electricity to flow. Adding the current path creates less overall resistance. And when we add a second and a third path, the more paths we add on, the less and less resistance we have for current to flow from the top to the bottom. And here's another analogy. I don't know how many of you do this. I think it's 2 L's. Maybe it's a single L. Colander. Yeah, single L. Colander. Okay, how many of you do not know what a colander is?
I don't.
Okay, that's one.
Is that what you filtered through?
Filter
Filter.
through, yeah.
Water through rice.
There you go. You use it in the kitchen. It's mama's food strainer, yeah? If you go to your kitchen stores, and you're not going to ask them for a food strainer, you're going to ask them for a colander, and they're going to give you something that looks like mama's food strainer. It's what you wash your vegetables in. So imagine if you had a bowl, a regular salad bowl. It has a lot of resistance. No water in that bowl is going to flow out. But the moment you put one hole, a ½ inch hole, somewhere in that bowl, will water flow out. So imagine, if you will, we have a bowl. And we put one hole in here, and by putting in one hole, we have water flow out. And that's what one resistor represents. One resistor represents a certain amount of resistance. When we add a second resistor, we've created another current path. When we've added the third resistor, we've created a third current path. So overall, the total resistance of this bowl, your RT, has gone down. It has diminished by adding more and more current paths using these resistances. The other thing for you to make note of is this. In your electrical terms sheet, and it raises a reminder for me, but in your electrical terms sheet, there is a concept, and the concept is known as conductance. And there is a concept symbol. And then there's units. And then, of course, there's also unit symbol. Then at the end, we have a brief definition. But the concept of conductance is given with a symbol, and it's shown as a capital G. The units of conductance, and there's two ways there's 2 units. One unit is MHOS, and you pronounce that mhos. Does mhos look like the word ohm spelled backwards? If you take ohm and you spell it back, once you have an MHO, and if you have more than one mho, then you have mhos. The symbol for mhos is an upside down omega. So conductance is the concept. Concept symbol is G. The units are mhos, and the unit symbol is an upside down omega. And I said there's 2 units because here in the Americas, we've been using mhos for a lot of years. In Europe, they have a different unit. It's still conductance, it's still G, but the units that they use is called Siemens, S-I-E-M-E-N-S, Siemens. In fact, there's a large European conglomerate by the name of Siemens, and they're huge. They're like General Electric and Westinghouse built all put together It's a huge, huge or conglomerate. And the symbol for Siemens is a capital S, uppercase S, okay? Now, the brief definition that we would give this, brief definition, would be the opposite of resistance. Conductance is the opposite of resistance. Resistance is the opposite of conductance. In fact, there's a very interesting relationship between the two where G is equal to 1 over R, R is equal to 1 over G. They happen to be reciprocals of each other, or inverses of each other. Same idea. Now, that being said, if you think about the formula that we've used for calculating RT, didn't we calculate RT as equal to 1 over R1 plus 1 over R2 plus 1 over R3? Didn't we use this? And isn't RT equal to 1 over, check this out, very, very profound here. This 1 over R1 is G. Isn't that the same as G1 plus G2 plus G3? Each one of these fractions of 1 over R1 is in fact a G, a conductance. This 1 over R2 is basically G2. The 1 over R3 is G3. Well, when you have conductances all together, guess what? This becomes RT is equal to 1 over G total. Isn't this what we wrote? Isn't this right here what we wrote right over there? Are they not the same? R is equal to the reciprocal of G, so R total must be the reciprocal of G total. Very interesting thought. So mathematically, the conductances come back to help us understand what's happening in the board. The conductances help us understand what's happening in the board by adding in one more thin pipe. We've made one more path for current to flow, one more conductive path for electricity to flow. Adding in a third pipe, we've had another path for current to flow. So altogether, if we add this conductance plus this conductance plus this conductance, we have a total conductance, and the reciprocal of that is RT. Interesting thought. Now, something else about parallel circuits. Let's jump in here. I just wanted to show you this, that yes, you are going to confirm using this particular circuit sometime next week with some other circuits that I'll have you build next week. What we've got assigned for this week is plenty for us to do, but I have some other fun circuits for, there will be parallel, and then there will be series parallel, and then parallel series circuits, just to throw out some words at you. But there'll be more fun and thought-provoking circuit builds. Any questions about that so far? Okay, a couple of bookkeeping things I wanted to share with you, and that was specifically book, as I made mention to you of this before, and let me go ahead and focus on here. Cool. That you should have your information put into a composition book. Well, some of you may not know how to get this thing started, so I'm going to take pictures of this particular guy and post it into Canvas on probably on the week 1 PowerPoint. But so what I have going on here is, and I recommend, this can be anything as long as it's bound. It could be spiral bound. It doesn't have to be graph ruled, but I find graph ruling makes drawing circuits and graphs and other things much nicer. The important thing is you handwrite what goes in here. So what I happen to have in this particular guy, ESIS notebook, I've created an index. I'm going to have page numbers for different topics as I generate the different pages. But looking at here, okay, did we not talk about atomic theory? Whose model of the atom was it? Or their subatomic particles? What does sub mean? This means these guys that are inside the atom. We talked about the different ones. We talked about where they existed. We talked about what their polarities, what their charges are. We talked about the valence band, being the outermost band. What was significant about it? We talked about it. We had talked about free electrons. We talked about how to free electrons by applying energy. We talked about 7 different ways of applying energy. What happens when you free an electron? You create something called a hole. What is a hole? We talked about that. I wrote it down. We talked about free electrons. Once you free the electrons, what are they good for? Okay, we can free them. We can apply energy in the form of these, and we can free them. What are they good for? Well, we talked about that, and I wrote that down here. And you get this information from the our lecture and also from the PowerPoints that I've generated. So here's an example of a very useful page that I can use as a reference in the future. Here's another one. The law of electrostatics. Like charges repel, unlike charges attract. Electron current model. We talked about electron current model versus the conventional current model. Did conventional current model have another name? Also known as, AKA, what? Pole current. Is it written down? Does it show how current flows with respect to a voltage source? Does it show how current flows with respect of flowing through devices? Yes, it's here. This was part of our PowerPoint, part of our lecture. Current flows from positive to negative in conventional current flow. Do you show electricity flowing from positive to negative here? And does it show positive to negative here? Then we talked about DC. We talked about DC. We talked about AC. We talked about what DC sources look like, AC sources. And I remember a classmate asking me, well, I've shown it with 4 plates. It's also shown with 2 plates. It's also shown with 6 plates. Any one of these possibilities can exist in our schematics, and you are to recognize this arrangement, whether it's 2, 4, or 6 plates, as DC voltage sources. Otherwise, with a little sine wave in the circle, that's a AC voltage source. Again, this is in your lecture. This is in your PowerPoints. Ohm's law. We talked about Ohm's law and talked about the variations of Ohm's law. Is it written down in your notebook? Is it handy for you to get to? We talked about electronic terms, the concepts of voltage, current, resistance, and power. Do you have the symbols written down? Do you have the units written down? Do you have the symbol use written down? Do you have brief definition written down? All of this is really, really handy for you as, again, as a reference when quiz or test time comes. And then resistor color coding. In resistor color coding, there was a mnemonic. There was the sequence of colors, the sequence of numbers, and the tolerances with respect to gold, silver, and no band tolerances if it's a 5-band resistor. And was there some discussion about how to decode 4-band resistors versus 5-band resistors? Was there a discussion pertaining to decimal multipliers? Yes, there was. Were there decimal multiplier shortcuts? Yes, there were. Is that, again, written down that you can go to as a ready resource? So I wanted to take a moment and show this to you, that if you hadn't taken the time to do this and you're scrambling around, trying to take a quiz, trying to take a test, and say, oh, where'd I put that? Where'd I put that? It should be in your notebook, and it should be in some format. You know, use your own style, use your own method. Why did I write only on one page and not the other? If you use a ballpoint pen, you can write on both pages. I happen to be using gel ink, and gel ink sometimes bleeds, and so I choose only to write on one side, and that way the ink on the reverse doesn't bleed through. So I'm not wasting paper. I'm letting this bleed and so that I can have this be legible and not have the bleed through on the reverse side come through. Okay? So, but again, it's your notebook. It's however you want to put it together. What information is most useful to you on a forthcoming quiz or test? you should have written down so it's immediately available to you. Okay? Any questions about what to do with respect to your notebook?
Will you be,
And yes,
will you be grading our notebooks?
I will be grading two things. I will be grading the notebooks and I will be grading your binders. The binders are set up as I've suggested before. Let me see if I can get this a little further away. You can see more of the binder. You can't get, okay. So you're repurpose a binder. You don't have to buy a new one, but you should repurpose a binder. So somewhere in the house of a binder, it's going to be repurposed for our course. And I said that the binder itself was worth several hundred points. So how are you going to show me the binder? We're going to have a binder check sometime, say Thursday of next week, not Tuesday because we have a test on Tuesday, but Thursday next week, we will have a binder check and you're going to show me your binder. And you're going to show me that in the binder, you should have your dividers. And if you can't get your hands on dividers, then what you can do is get Post-its and put little tabs. You just tab papers on the side or something. So you have a week 1 section, you have a week 2 section. So what do I have at the beginning of week 1? In week 1, I happen to have my deliverables. And my deliverables, as what I've stated to you before, it was 465 points. As you have accomplished and completed each one of these, you check them off. And it's a really good place is at the beginning of week 1, you have this. What did we do in week 1? You should have printouts of your Ohm's Law, multimeter homework practice, a breadboard fill-in. We also had resistor color coding and some basic tolerances, electronics terms. Then we get into week 2. Week 2, there was a deliverables of 465 points there with your checkoffs. And in week 2, what do we have? Well, in week 2, we happen to have had this. We happen to have circuit G, circuit F. We happen to have resistor color coding, Ohm's Law calculations. We also happen to have more Ohm's Law calculations here, and more Ohm's Law calculations, and of course your homework. Then in week 3, do we have our deliverables? And in week 3, we have this so far. There's going to be a quiz. Yes, there's circuit G that you're working on, circuit F, circuit H, E, F, G, H. Oh, H is coming. Okay, then your parallel circuit calculations there. And if you don't have the ability to print things out, I understand, you can still write out your answers on an answer sheet and have them jammed into the binder on a chronological basis, okay? And so that's what it is that you should have and start accumulating. So your binder is going to be checked, progress checked next Thursday, and the note will also be progress checked next Thursday. Did that answer your
Mr.
question?
Cove,
Yes.
last time I remember that you said it was okay to do a Google Drive if we put it in order. Is that still valid? Because I've been
It's
doing
still
that.
valid. Yes, it's still valid. Yeah, I just need to see your organization by next Thursday, what you've done.
Sounds good. Thank you.
You're very welcome. Okay,
Sorry.
go ahead.
What will you be looking for in the notebook? Because like my personal style is not really writing much, but listening. So I don't really have much here.
Okay. Well, if you at least have your say your resistor color coded bands, if you at least have your engineering terms, if you at least have your powers of 10 spelling out, what's a mega, what's a pico, what's a micro, what's a nano, what's a tera, what's a giga. If you have all that in some sort of order, then yes, that serves you equally well. So some information in your notebook of that will be sufficient.
Thank you.
You're welcome. All right, we want to take a peek at our textbook. Couple of things is I didn't notice yet. Let me do this. Let me take us off this camera. Go back here for a moment. All right. And let's take a look and see. Javier had a question earlier. Is Javier here? No, Javier.
Yeah, I'm here.
Where are you? Oh, there you are, Javi. Excellent. Did you read my response, my friend? You asked the
To look
question,
at
and I
page.
responded. You asked the question in Discord. Good question, and I responded in Discord. Did you get a chance to look it up yet?
No, not yet.
Ah, okay. Could you go ahead and reiterate your question to the rest of the class, please?
Yeah, let me open up Discord.
You forgot your question?
Oh, if you want me
It's
to
all
read
right.
it verbatim.
Okay, go ahead.
Okay, here you go. Can you explain to me how a circuit with both leads connect to the ground works? I can't find it in the book. I always thought ground was a sink that could accept an arbitrary amount of electrons.
That's a very, very good question for a number of aspects of concern. And if we're dealing with electrical systems, if we're dealing with a course in electricity, if you were looking to become an electrician, ground has a little different meaning for electricians than they do for electronic technicians. Ground for electricians is has to be clarified. Are we talking about earth ground, or are we talking about a chassis ground? And if we're talking about earth ground is a sink for all electricity. So every single house, every single apartment, wherever you live, all the electrical outlets are grounded. And what that means is of the three prongs, there's three prongs in your power cord. Of the three prongs, one of those pins that goes into the socket is a ground pin. And the ground wires in the wiring in the building where you live and the place where you work, all of the grounds are tied together in the building all the way down to physical ground. And in the ground, outside the building, there are 8-foot long stakes, 8-foot long rods that are driven into the ground. And then the electrical wire called ground of the building is tied to those 8-foot long poles. And that way, any potential hazard with respect to electricity will go to ground and not cause a problem unless there's a short circuit somewhere. Now, for us, electronic technicians, we're not dealing with circuit ground. Our ground is a chassis ground, and that's the other ground that electricians have to be aware of. They have to learn, and they do where I teach over at Laney. I teach the electricians. Yes, there's a circuit ground also, and the circuit ground is a reference point within the circuit that you're building. So in the homework exercise, one of the questions for week 2 homework was a circuit that showed ground in 2 different places. And it looks a lot like this arrangement. And let me go back to this real quick for you. And go, okay, cool. All right. And let me go to snag the entire, okay, cool. Sorry. So what they had was something like a source, a resistor, and possibly an LED or a lamp or something. And they showed ground over here, and they showed ground over here. And they're asking you, will this LED light up? Okay, will the LED light up? And not having taken this class before, not having heard this discussion, or also not having read the literature behind all of this, first of all, for many of our classmates, we're thinking, wow, maybe we have this situation. It's either an exclamation mark or it's a question mark. Is there continuity? Is there no continuity? Because it sure doesn't look like there's a path for the electricity to flow. It looks like all the electrons from the short plate are going to go into this thing called ground. And unless we're told otherwise, it looks like it's just going to go there. Actually, it turns out for us, it is implied that we have a connection between the two grounds. Okay, so fundamentally, ground is the same point, no matter how many times it appears in a schematic. And it would be one of these, it would be an example of one of the things that you'd write down in your notebook. Ground is the same point no matter how many times it appears in a schematic. There is an implied connection between grounds, and I'm abbreviating ground all over the place. It is an implied connection between grounds. So although I show you a ground here and I show you a ground here, there is an implied connection. And yes, this is not an earth ground. This is a chassis ground, and it is shown so that electricity will flow like this back to the source. And yes, this LED will light up. And it is also pointed out in your literature. Specifically, I noted page 144 and 145 of your Del Mar textbook. And if I go to, let's go to here, and let's illustration. This is okay. So I want to go page down, 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 down. Cool. Let me go ahead and share this screen with you, my friends. Go to here, actually go to here and share. All right, you can see the textbook, yeah? And as we're looking at the textbook, let me make it a little bigger and do this here and make it a little bigger. And I want to go to page 144. So, all right. So on page 144, your textbook cites using reference, ground as a reference. And it makes note of ground in a circuit on the next page. It shows chassis ground and it shows earth ground. And interestingly, for all our schematics, we don't use this one for chassis ground. We actually use this illustration for chassis ground. And if we take a look at the very next page, right here, this goes to show a real world circuit. This happens to be a circuit of a burglar alarm with a battery backup. Bigger, cool. And just moved it too far. Sensitive, sorry. All right, just try nudging it just gently. Okay, so we happen to have a ground here. Center tap of the transformer, we have a ground here at the bottom of a capacitor. We have a ground here, the bottom of a DC voltage source. We happen to have a ground here at the bottom of an LED, bottom of this LED. We happen to have a ground here, which is the bottom of your alarm speaker system. We happen to have a ground over here. All the grounds are the same point. All the grounds are interconnected. This illustration is shown what we call in the open loop. And by showing ground this way, it results in a cleaner looking schematic. So if you just simply, whenever you see circuits like this and come to understand that wherever you see these circuit ground, they are all interconnected. These are all what we call the bottom of the circuit for this particular circuit design. As the circuits become more sophisticated, you'll see more and more multiple grounds. So this is the very first illustration in your textbook, chapter 6 on series circuits regarding ground shown in more than one place. And it references that they are the same point. In fact, if we come here to the definition, ooh, yes, right here. Numerous ground points in the schematic. In practice, when the circuit is connected, all the ground points will be connected. Okay, and I can take this guy and boom, highlight it. Bam, right there. Everybody okay with that concept and where in the literature we can cite it? Kirsten has a question.
Yeah, so on the schematic, there is a transformer with ground, I assume, inside it.
Yes. Yep.
So then how, I'm still trying to wrap my head around how ground is connected throughout. Are they all like chassis grounded?
They are all chassis ground. Yes, this is the
Okay.
center tap for the secondary of the transformer. We use this very often in the power supply. I have E56 class that happens on Wednesday nights next semester, in the fall semester, and we will be into this circuit intimately, where the students will be building their own DC power supply, their own benchtop power supply. And one of the critical components is this very transformer. The transformer is an iron core, has 120 volts on this side. We'll have a switch, we'll have a fuse, and we'll have a center tap on this side. And instead of using 2 diodes, we will be using 4 diodes for more sophisticated reasons. So just to give you the assurance, yeah, this is hooked up to chassis ground and is electrically the same point as the bottom of this capacitor, electrically the same point as all the rest of this. The answer is yes. And when we get into that particular course, I'll be able to show the students how the electrons actually work in this such that everything makes sense.
Thank you.
You're welcome. Good question. All right. Any other questions regarding grounds in more than one place? Okay, let's see. Another thing that I wanted to look at was okay, conductances, Ohm's law, that's good. Parallel, that's good. Let's see. Missing values. Missing values. Oh no, you can calculate that. That's pretty straightforward. No, I was just looking over the homework questions, the review questions for this week. And since we've had a chance to talk about conductance and everything else you have done already since Tuesday's discussion, I don't think there's anything that is going to be of any challenge for you on the review question homework. Did anybody have any questions with respect to the parallel circuits that you all calculated? Let me stop the share and go to here. And go to here.
Hey, was that circuit that you just had up, was that for a car?
Was that for a car? No, it had a 120 volt source. So
Oh, yeah.
it was a circuit for a burglar alarm, but not a car alarm. Okay, it is an alarm system, which is easily adaptable to put into a car. But this particular circuit that was in your textbook on page 144 is a burglar alarm or any kind of security system for whatever you want it for. It could be for something as small as your office or something as large as a building. So that's what that was for. Okay, good question. Saw the
No, I
alarm.
just get so confused with chassis ground because I work with cars.
I don't know, it's kind of weird.
Yes. Yeah. Yeah. And so with your, yes, with your chassis ground, it is a return path for your battery because your battery is hooked up to ground. Yes. The ground terminal is hooked up to chassis.
Yeah.
Yeah. So all the electrons have to flow back. Yeah. It's a return path for your electricity to battery because ultimately it's got to go back to the battery.
Yeah.
Yeah. And so same thing with our circuits. So the analogy is the same. Oh, since I have Carlos on, Carlos, I just noticed something. Have you been in contact with our friends at admissions because your situation is still not resolved?
Yeah, I have. I actually I let a day lapse just because I was told that it's possible that there was an issue with the class not being officially dropped on the website, and so that might have been a problem. So I tried today to add the course, still got the same error, and they said that it's very possible that you will have to late add me, but I can discuss that with you on the side.
Okay, I was just curious if you happen to have had some resolutions. I was concerned about that.
Yeah, no, thank you. Me too. I do have an email. I'll share the details with you.
Okay, we'll talk about that afterwards then. Not a worry. All right. So with that being said, let me go ahead and do this, friends. I'll let you have your quiz now. So we'll go ahead and do this here. Now this is different from the little 15-point thing that you have weekly from Canvas. This is a quiz from me. So week 3, quiz from Kogai. And add that and do this. And let's go ahead and point value, yes. And the assignments are here. And yes, you will upload your answers online. File uploads. And will be tonight. And we'll put this in at okay. Let's see if we are before 7. Okay, let's say 8 p.m. It shouldn't take you very long, probably 10 minutes to do if that. Okay, save and publish. All right, so now let me jam the file in there so that you have it. Okay, and now find the file. Choose the file.
Is that on Canvas?
It will be in a moment.
Okay. I think I
It's
just
on Canvas already.
Well, I created the shell. I haven't uploaded the thing yet.
So
how
we have
many of
2
you
quizzes,
needed
right?
in PDF? How many of you needed in PDF format? Nobody? Okay, then I'll put
I'm
it
not
in
sure
Word
yet.
format.
Not until I try to open it. Oh, I guess I'll know.
Well, I'll put it in PDF format also, just in case. Okay, and save. All right, it's on now. And so while you're doing that, let me double check my roll sheet, make sure everybody's accounted for. So Luis is here. Harpreet is here. Ephraim is here. Is Erica? Yeah, Erica's here. Yay, Erica. Tawan is here. You all should be downloading that, printing it out, or doing your work on your quiz now. Javi's here.
I don't have access to a printer at the moment.
Well, then read it off the screen and write your answers down on a separate piece of paper. We'll be fine.
Okay.
Yeah.
It's called quiz 3, 8 questions. That one.
Week 3
find-
quiz, it's in week 3 Canvas, and it shows week 3 quiz for Kogai.
Professor, it's Carlos. Sorry for the inconvenience, but would it be possible to email me that and then I'll print it out and submit it to you since I don't have Canvas
Oh,
access?
yes, sure. Go ahead and put your email in the chat, please.
Okay.
No problemo.
Professor, is it okay if we turn the volume down until we're done with the quiz?
Yes.
Okay, thank you.
Professor, I just put it in the chat with everyone, so hope that's fine.
That's fine. I just sent it to you. So check your email. Carlos, can you confirm your email, please?
So sorry. It's Carlos Navarro 017 at Gmail.
Yeah, I copied and pasted it.
Okay, thank you.
So let me know when you've received it. You might want to check your spam folder also.
Professor, when we're done, what do we do? Do we submit it online?
You upload it. You upload it. Ephraim, I don't see that uploaded yet.
Sorry, I was changing it to PDF.
Oh, okay. Thank you.
Okay, on my side, it's down, uploaded.
Okay, I'll refresh my screen. Okay, Fran, I have your copy. It's been received. I will be grading it this evening, and you are excused until Tuesday.
Thank you, Professor. See you next week.
Have a good weekend.
You too.
Thank you. If any of you happen to have questions or along the way, I can't give you the answers, but I might be able to point you in the right direction. If there's some misunderstanding or confusion or something that I've worded that is confusing, please let me know. I will help clarify anything that may be ambiguous.
Mr. Coe, I just submitted mine.
Who is this?
Erica.
Erica, let me take a peek. Let me upgrade my screen.
I also turned mine in.
Cool. Javier, all right, so let me upgrade the screen, update the screen. Okay, Erica, yours has been received. I'll be grading it a little later on this evening. Everything looks clear, so good so far. You're excused for the evening.
Thank you.
Oh, I
Javier.
also submitted it, Luis.
Okay, Javier, let's take a look at yours. See if everything came through clearly. You've got to take your pictures without having shadows in here, my friend. Those shadows are killing me.
Okay, I'll resubmit it.
Yeah, take a look at your own picture. You got shadows on shadows and it makes it really hard to read. If you could re-upload that, that would be great. Thank you. Anna, hold on one moment. Let me make sure everything is clear and legible on yours. Everything is clear and legible on yours. Anna, you are excused for the evening. Have a lovely weekend. Be safe on 4th of July.
I just submitted mine too, Mr. Coe.
Cool. I will go through the list. Okay, Luis, hang on. Let me make sure everything came out clearly. Okay, everything is clear. Luis, you are excused for the evening. We will see you on Tuesday. Have a safe 4th of July.
Thank you.
You're welcome.
I don't remember if you mentioned this before, but can we turn it in? Like, can we just fill it out in Word and then send that document to you?
Oh, sure. That's what you can, yeah. Since I made it available in 2 formats, a number of classmates have been filling it out in Word and then updating that copy with all the answers. So that's perfectly fine, Dana.
Okay, great. Thank you.
Thank you.
I just submitted mine, Mr. Coe.
Okay,
Right.
let me keep on going through the list.
I resubmitted mine.
Cool. I'm just cycling through from the top of Canvas. Okay, let me refresh the screen and see a whole new batch.
I just turned mine in, Frank.
Okay, cool. I will, I just refreshed the screen, so I should see the latest batch of uploads in just a moment. Nice. Okay, Harpreet, I have yours. You are excused for the evening. Have a good 4th of July holiday.
All right, thanks. You do the same. Thank you.
Thank you, sir. Thank you. Oh, much cleaner, Javier. Hold on. Let me see if I can read all the different parts. Okay, everything is there. Thank you very much, Javier. You are excused for the evening.
Thank you.
Thank you. Have a good holiday. Tony. Let's see what you got here. Okay, everything is on here. So I have you. Okay, Tony, yours has been received and you are also excused for the evening. Have a wonderful holiday.
You too. Okay. See you later.
Thank you. We'll see you on Tuesday. Study hard. We got a test on Tuesday.
Okay.
This is like a preview.
All right.
Ryan Huey, let me take a look at your paper. Make sure all the elements are there. Looks like it's all there from Ryan. Okay, so for Ryan Huey H, it has been received and you are excused for the evening. We'll see you on Tuesday. Have a great holiday.
Okay. Just wondering, do you know how many questions are going to be on the test?
It'll be pretty much the same amount. It'll just be worth more.
Okay, thank you.
I got a whole lecture to do, so I don't want to spend a whole lot of time on the test.
All right, have a good evening.
Thank you. Bye.
Did you see mine? Did you get mine?
It's coming. Yeah, I'm going alphabetically from the top every time I refresh the screen. So I will get to you, Dana. Yours is coming right up. There you are. Okay, let me take a peek. Make sure all the giblets are in place. Yep, Dana. Okay, your paper has also been received. Thank you very much. Have a lovely holiday weekend, and we'll see you on Tuesday.
Thank you. You too.
Thank you.
Professor, I just emailed you a picture. Do you need it converted to a PDF?
No, I will open up email in a moment.
Professor, this is Carlos. Also, do you have a few minutes after lecture?
Yes, certainly.
Thank you.
I sent mine through text. Is that okay?
Yes. Who is this?
It's Frank Francisco.
Okay. All right. I will look for yours in a moment. I'm staring at a classmate's
Okay, take your time.
No. Okay, Mr. Navarro, yours has been received, and we'll have a conversation afterwards.
Thank you.
Thank you.
Hi, Professor. Do you want them highlighted?
No, it won't be necessary, but
Okay.
yeah, thank you.
Mr. Core, I just submitted.
Okay, I will, I just refreshed my screen, so I'll be looking at a bunch more here in just a moment. Frank, you said you uploaded text information. I didn't see anything come through in Canvas.
Oh no, to your phone.
Hold on. Okay, Mr. Doe, I have received your quiz, and you are excused for the evening. Have a safe holiday and be ready for the test on Tuesday.
Mr. Ko, I just submitted it.
Cool.
I just did too.
Wonderful. Let me refresh the screen.
Ah, never mind. I'm going to resubmit. I totally missed something.
Okay, glad you caught it before I received it.
Sorry.
Okay. Let's take a look here. Chisamaga, let me take a peek and see what we got. Okay, Chisamaga, your quiz has been received and you are excused for the evening. Good job and have a safe holiday weekend. We'll see you on Tuesday. Be ready for the test.
Okay, thank you. See you then.
See you then.
Okay.
Okay, Frank, your document has been received and you are excused for the evening. Study hard for the test on Tuesday. You'll get the results in the next 24 hours on these quizzes. So keep an eye out for comments.
Okay. Thank you.
Have a good holiday.
You too. Bye.
Thank you. So we want the one at 7:34 instead of 7:31, eh, Kirsten?
Yes, I was muted. Sorry.
Okay, yours has been received as well. And you are also excused for the evening. Have a safe holiday weekend, and we'll see you Tuesday for your test.
Have a good weekend.
Okay, thank you. Carlos, do you have Discord on your screen?
Yes, I have it up. Give me 1 second.
Cool.
Yeah, it should be on here. I think I opened it when one of our classmates gave me the Zoom address for this.
Mm-hmm.
Are you?
So here's the thing. You were asking at 10 minutes after 6, is there a Zoom session this evening? When I posted in Zoom before 6 what the Zoom link was. So is Discord set up? Yes. Is Discord set up on your cell phone that you get a ping when notifications come up?
I don't think it is, but I'd like to get it up there. I think I'm getting the emails right now, but I actually have the app and would like to connect it. So yeah, I apologize. I apologize for that. I was on the link that I guess was an old link. I apologize. I feel embarrassed, but I will get it together.
No, don't feel embarrassed. I'm not slapping your hand. I just want to make sure that you understand how to use Discord properly to your advantage, so it can be a help to you.
Actually, if I can ask you a question, I actually don't know how to, because when we met on our first meeting, you gave us, I believe, a link to Discord, right? And I don't know how, and I set it up, and I don't know how to connect it to that on the app.
Are you using Are you using Android or are you using a iPhone?
iPhone.
Okay, there is a Discord app on iPhone, so download the app, and then I can give you the link again to us, and I can send that to you by email.
Okay.
Professor Ko, did you get my quiz?
Greg? since I will be happy to look for it in just a moment. Yes. Okay, Carlos, the Discord invite link is in email. And Greg, you're an animal. You have finished all the Khan Academy already.
Yeah, I had some free time yesterday.
Yeah, it showed like black. Wow. Half a dozen of you finished it all up already. And I only assigned it, let's see, Monday. Good job. All right, let's take a look and see what we've got here. Refresh the screen. Okay, now let me come over to here. Hello. Let's see what this looks like. Okay, I see all the spaces filled in, so nothing's missing. All right, yours has been great. Keep an eye out for the results. I'll have them turned around in 24 hours, and that will help you better prepare for Tuesday's test. Have a safe weekend.
Cool. Thank you. You too.
Thank you. Abbas, how are you coming along?
I'm doing sort of fine. I figured out the rest of them like decent, but then like I'm stuck on the first one.
The VIRP?
The VRP, yeah. It's mainly the VS that's kind of tripping me up.
VS is your voltage source.
Right. Well,
Your
so that
voltage
would
total.
yeah, that would be total, right?
Yeah.
Okay.
Yeah. Don't sit there in a fog. If there's something, as I said, I threw out an invite that if anybody had a question along the way, don't sit there and be confused. Go ahead and throw out the question. Yeah, I can't give you the answer, but I can at least point you in the right direction. So VS is your V total. Carlos, were you able to upload the app into your phone or download the app to your phone?
Yes, I'm working on the password now, which apparently I forgot. So yeah, but I'm gonna get on right now. Okay, and I am live on the phone, so I'll make sure I stay on top of correspondences and hop on there as well.
Okay, so while you're live on the phone, let me correspond with you about something I need to, so we can test how well you're receiving information on Discord. Hold on just a moment. You finish one task here. Cool. Okay, so find Discord. Okay, I just sent you a message. Are you able to see my message?
Yes.
Cool. All right. Abbas, can you finish in about 5 minutes? Do you think that's enough time for you, Abbas?
Oh, yeah. Yeah, I figure I just realized what to do now, I think.
Okay. And Carlos, I gave you an exercise in Discord.
Okay, thank you. And I actually have a question about that when we get a minute. About the topic, not the assignment.